All right, so we're going to start the notes, and notice how I kind of clumped all of the graphing together. So these are going to take a while. There's going to be quite a few videos, and I seem to be having a problem with my contraption. It keeps falling, so be aware of that. But you can probably see that I typed these notes on my own because I want to condense graphing. You're going to get everything you need to do. You're going to be able to graph any function that they give you. But I took out the explorations and things for something like this because I gave it to you all in bullet points. I hope you appreciate that. All right, so let's go ahead and let's talk about the sine function. We're going to go through each one of the 6 individually, and we're going to look at basically the parent graph, the very basic graph, before we then go ahead and we start shifting them around. So first of all, your sine function is a function of this form, where the absolute value of A is called the amplitude. And when we go ahead and when we graph it, you're going to see what amplitude means. But basically what that means is it's how high it goes up and how high it goes down. The period, remember, that means how far you graph before it begins to repeat itself. You can get for the sine function by taking 2 pi and putting it over the number b. Now, although for the beginning here we're not going to have any shifts, your C is your phase shift, which is also your horizontal shift. It means the same thing. And then your vertical shift is your D, which is at your end. Okay, so again, we're going to go through the very basic functions first, the parent graphs. So the amplitude of the sine function is 1. And you'll see what that means when we go ahead and graph it. The period is, again, 2 pi over 1, because the number in front of this theta is a 1, so it's 2 pi. There's no phase shift, so that's 0, and your vertical shift is 0, because these are very basic. So here's what I want you to do, and you're not going to like it, but that's tough. When you go to graph these, I want you to graph for me, please, 2 periods. So what you're going to do is you're going to go ahead and 1, 2, 3, on the 4th space, you're going to put 2 pi, that's 1 period. And then 1, 2, 3, 4. Out here, we're going to put 4 pi. That's going to be our 2nd period. Okay, each of your periods is going to be divided into 4 parts. So when I go ahead and when I label my graph here, I usually like to go to this one first. So half of 2 pi is 1 pi. And then half of that pi is going to be pi over 2. Don't use degrees. I want you to do it in pi radians. So then we can actually, once you have this one, you can just count 1 pi over 2. This is 2 pi over 2. 3 pi over 2. 4 pi over 2. 5 pi over 2. 6 pi over 2, which is 3 pi. 7 pi over 2, and then of course you have 8 pi over 2. And we're going to put a 1 here, and we're going to put a negative 1. Okay, so now, hopefully you know these are all your quadrantals and you know your sine function. So for example, if we start at 0, plug it in. What is the sine of 0? Well, the sine of 0 is 0. The sine of pi over 2, which is 90 degrees, is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is, of course, the same thing as the sine of pi, which is 0. Notice that is 1 period. And now it's just going to start to repeat. So we're going to go up to 1, down, down to negative 1, and 4 pi would end up on 0. Again, you don't need to plug in a million points. That is what 2 periods of the sine function looks like. So the amplitude is 1 because from its midline, kind of right here, it goes up at most 1 and down at most 1. So you can put arrows on there because technically it keeps going on and on forever. If I look at the domain of this function, the domain is going to be all real numbers, and the range is going to be from -1 to +1. We've already talked about that, so we're not actually going to do the domain and the range for all of them, but I wanted you to get a visual that that's actually what it means. So let's look at the cosine function. So here's the general form. All of the A, B, C's, and D's mean exactly the same. The period for cosine is still 2 pi over b. So your amplitude is still 1. The period is 2 pi over 1, which is going to be 2 pi. There's a 0 phase shift and a 0 vertical shift because we're just doing the parent graphs. So once again, since the period is 2 pi, 1, 2, 3, we're going to go out to 2 pi and then go 4 more out to 4 pi. Label all of the quarter marks, please. So half of 2 pi is pi. That makes this pi over 2. That's 3 pi over 2. This is 5 pi over 2, 6 pi over 2, and 7 pi over 2. Now, let's think of the cosine here. The cosine of 0 is 1. This is all from knowing your unit circle. The cosine of pi halves is 0. The cosine of pi is -1. Cosine of 3 pi halves is also 0. And the cosine of 2 pi would be the same as the cosine of 0, which is 1. So there's one period. Oops, I missed. And now it just begins to repeat, so we don't even have to really think about it. You should be able to just go ahead and finish it. So again, because of the arrows, your domain for this guy is negative to positive infinity, and your range is once again, as we already knew, from -1 to +1. So notice the sine and the cosine function look exactly the same. One is just shifted pi halves, or 90 degrees, to the right. Okay, now let's look at tangent. First of all, sine and cosine are the only two functions that have an amplitude. None of the other four do, and we'll see why when we graph this. So when you see amplitude, you'll see none, no amplitude. The period for tangent is not 2 pi over b, it's pi over b. Just like before, the phase shift is c and the vertical shift is d, but we're not going to worry about that. So you can see that the period would be 2 pi over 1, or no, I'm sorry, 1 pi over 1, so it's just pi. The phase shift and the vertical shift are 0. Now, for tangent and only tangent, we're going to do something a little bit different. We're going to center our first period around the y-axis. And when we actually do the graph, you'll see why I do this. So that means since the period is pi, this first period will go from negative pi halves to positive pi halves. That's a grand total of pi. And then, of course, this will be negative pi fourths, and this would be positive pi fourths. Okay, so I need to go in the second period. It's going to be over here. So 1 pi fourths, 2 pi fourths, 3 pi fourths, 4 pi fourths, 5 pi fourths, and 6 pi fourths. Now, why did I do this? Well, if I'm at negative pi halves, let's just for a minute, we shouldn't have to do this, but let's go ahead and think of our unit circle like this. Remember, it's cosine sine. So remember, the tangent is the y over the x. If I go down to negative pi halves, that's right there. What happens when I take the y over the x? I get an undefined value, which means that there's going to be an asymptote on negative pi halves. If I go to 0, would be y over x. That's 0. What happens if I go to positive pi halves? Positive pi halves is up here. If I do y over x, there's another asymptote. So let's just quickly look at this first period here. Pi force, what is the tangent of pi force? That's 1. And the tangent of negative pi force down here is going to be negative 1. This is what one period of the tangent graph looks like. Notice there's no highest level, no maximum or minimum, which is why there's no amplitude. Okay, so that's one period. I like to center that period around the y-axis because if you think about it, if you didn't, and if you just went from 0, you'd end up with like part of a period, part of a branch, which just looks weird. Okay, so you can see every 4 units, there's going to be an asymptote. So when I do my second period, there'll be an asymptote there. And again, I just have to repeat what I did. And you're going to get a graph that looks like that. So there's the second period. So that's tangent. So if you look at it, remember when we talked about domain and range before, the domain is all real numbers except for odd multiples of pi over 2. So 1 pi over 2 is bad, 3 pi over 2 is bad, negative 1 pi over 2 is bad. That's because that's where the asymptotes are. So your domain would be all real numbers except for odd multiples of pi over 2. Your range, you can see, is all real numbers, just like we talked about before, but visually it makes a little bit more sense. Okay, I think I'm going to stop this video right here.